Consistency of a linear system of equations. Now consider the system of m linear equations in n unknowns. a11 x1 plus a12 x2, a1n xn is equal to b1, etc. These n equations. Now we can write the constants of these equations in a matrix form. That is, a can be written as these constants of the left hand side. So a11, a12 up to a mn. Now this matrix is called as coefficient matrix, and if we add these right hand side constants to this matrix, that we can write like this. Now this matrix is known as augmented matrix. The constants of left hand side, when we write it in the matrix form, it is a coefficient matrix. When we add the right hand side constants to coefficient matrix, we get augmented matrix. Now if rank of this matrix is less than this rank of a comma b, then we call this system as inconsistent and the system has no solution. And if rank of a is equal to rank of b, then this system is consistent and it will have at least one solution. So if rank of a is less than rank of a comma b, system is inconsistent, and rank of a is equal to rank of a comma b, then the system is consistent. Now consider a problem. Examine the consistency of the equation 2x minus 3y plus 5z is equal to 1, 3x plus y minus z is equal to 2, and x plus 4y minus 6z is equal to 1. Now consider the coefficient matrix that are constants of left hand side. A is 2 minus 3 5, 3 1 minus 1, 1 4 minus 6. Now to check whether the system is consistent, we need to find the rank of the coefficient matrix and augmented matrix. Now to find rank, we need to find determinant. So first let us find the determinant of A. Now when you consider this one, we will delete first row and first column, so remaining is this. Now minus of minus 3 into, when you delete this, 3 minus 1, 1 minus 6, and when you consider 5, we delete this, so 3 1 1 4. Now you know to calculate the determinant, we get determinant to be equal to 0. So rank of A is not equal to order n, therefore we will delete first row and first column, or otherwise you can delete first row and last column. So the remaining is minus 3 5 1 minus 1. Now find the determinant of this. Minus 3 into minus 1 is plus 3, minus 5 1 is 5, so it is equal to minus 2. Determinant of this is non-zero, therefore rank of A is n minus k. Now n is order of A. Now order of A is 3, and k is the number of rows and columns that we delete. So we deleted one row and one column, therefore k is equal to 1. So rank of A is equal to 2. Now we need to show rank of A is same as rank of the augmented matrix to show this system of equations is consistent. Now the augmented matrix is 2A. We add the one more column, that is of constant of right hand side. So 2A we added 1 2 1. So now to find the rank of this matrix, we need to find the determinant. Now since this is not a square matrix, we will delete the first column and consider the square matrix. Now do not delete the last column, because if we delete the last column, we will get the matrix same as A. So it will obviously rank of A will become rank of A comma B. Now if we do the same thing in every matrix, we will obviously get this rank to be equal to same. So there is no need of having this consistency of linear system of equations. Therefore, other than this last column, we can remove the other columns. So I will remove the first column. So the remaining matrix is -3, 5, 1, 1, -1, 2, 4, -6 and 1. Now find the determinant of this. Now you know to find the determinant. Now this is determinant is equal to 0. Therefore rank of A is not equal to rank of A comma B is not equal to order of A comma B. Therefore we will remove rows. I will remove first row and last column. So remaining is 5, 1, -1, 2. Now determinant of this is not 0. Therefore rank of A comma B is n minus k. Now n is order of A. Now we considered this matrix to find the determinant. Therefore order is 3. And k, we removed one column and one row. Therefore k is 1. Therefore rank of A comma B is 1. Now since rank of A is equal to rank of A comma B, the given system of equations is consistent. So this system of equation is consistent. And next topic is vector norms and matrix norms. Now a norm of a vector, now we denote it by this, is a real number and it satisfies the following condition. Norm x is greater than or equal to 0 and norm x is equal to 0 if and only if x is equal to 0. Norm of alpha x is mod of alpha x into norm x for any real number alpha, and norm of x plus y is less than or equal to norm x plus norm y. Now this condition is called as triangle inequality. Now the matrix norm A is equal to Aij, we mean a non-negative number, we denote it like this. This also satisfies these three conditions similarly, that is norm A is greater than or equal to 0 and norm A is 0 if and only if A is 0. Norm of alpha A is the same as mod alpha alpha into norm A, where alpha is a scalar, that is it is a real number. Norm of A plus B is less than or equal to norm A plus norm B. One extra condition to matrix norm is norm of A into B is less than or equal to norm A into norm B. Now we can substitute this B to be equal to A. So we get norm A square is less than or equal to norm A into norm A. Now we can write it this as norm A whole square. So norm, if we multiply A p times, so from 4 we get norm A power p is less than or equal to norm A whole power p, where p is a real number. Now here only 2a we considered, so we can multiply p number of a's, so we get this inequality. Now we have three matrix norms. Now first one is a column norm, which is given as maximum of summation of mod of aij. Here I, that is row, varies and j, that is column, is constant. Second one is Euclidean norm, that is summation of mod of aij whole square whole power 1 by 2. Third one is the row norm, that is maximum of summation of mod aij. Here j, that is column, is varies and I, that is row, is constant. Now consider this matrix. Now we need to find column norm, Euclidean norm and row norm. Now first one is a column norm. Now formula for column norm is maximum summation of mod aij, where I is row. Now row changes and column is constant. Now this is constant, but row changes, that is we need to add first these three terms, then these three terms, and lastly this column. So we will add first 1 plus 4 plus 7, 2 plus 5 plus 8, that is second column. Third column is 3 plus 6 plus 9. Now maximum among these is 18, therefore column norm is equal to 18. Next is Euclidean norm. summation of mod aij square whole power 1 by 2. Now here both rows and columns changes, so therefore we will add squares of these numbers, that is 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square plus 9 square whole power 1 by 2. So we get this to be 16.88. Next is row norm, that is maximum of summation of mod aij. Now here column varies and row remains constant, so we add the terms like this: row constant and column varies. So 1 plus 2 plus 3, 4 plus 5 plus 6, 7 plus 8 plus 9. Here this is of first row, this is of second row, and this is of third row, and a maximum among these is 24. Now solution of linear systems. Here we have two types of methods, direct methods and iterative methods. In direct methods, first one is matrix inversion methods. Now consider the system of n linear equations in n unknowns. This we already consider this in consistency of systems. Now we can write it in the form of matrix form: Ax is equal to B, where A is constants of left hand side and x is these unknowns x1, x2 up to xn, and B is constant of right hand side. So now we assume that A is non-singular. Now A non-singular means determinant of A is non-zero. So to apply matrix inversion method, first you need to check whether A is non-singular, that is determinant of A is 0 or not. So if determinant of A is non-zero, then A inverse exists. So to this equation we can multiply A inverse from left hand side. So A inverse into Ax is equal to A inverse into B. So we know that now A inverse into A is equal to I, it is I, and I into X is equal to X. So we get X is equal to A inverse into B. Now this X is the solution matrix. To get solution of given system of equations, you need to first find A inverse, then multiply B into A inverse. So now consider an example. 3x plus y plus 2z is 3, 2x minus 3y minus z is minus 3, x plus 2y plus z is equal to 4. Now we can write A to B, we can write this system in the form Ax is equal to B. So A is equal to 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1. X is unknowns are x, y and z, and B is 3 minus 3, 4. Now first we need to check whether we can apply matrix inversion method. Now to know that, we need to find whether A is non-singular or not, that is the determinant of A is 0 or not. So let us find first determinant of A. Now we get determinant of A to be equal to 8, which is non-zero. Therefore we can apply matrix inversion method. Now to find the solution matrix, we have the formula x is equal to A inverse into B. So first we need to find A inverse. Now to find A inverse, we have the formula 1 by determinant of A into adjoint of A. Now we already found determinant of A, so we need to find adjoint of A. To find adjoint of A, first we need to find transpose of A. So this is A. Now exchange the rows and columns. Now this is a column here, so we write it as row. So find A transpose. So I have written A transpose. Now to find adjoint of A, we need to find cofactors, and to find cofactor, now cofactor is Aij is equal to minus 1 power I plus j into Mij, where Mij is minor of Aij. So to find adjoint of A, we need to find cofactors of Aij, and to find cofactors of A we need to find minor of Aij. Now let us find minor of Aij. Now first let us consider A11, that is this term. Now to find minor, first we will delete the row and column which contains the A11. So remaining matrix is minus 3, 2, minus 1, 1. We have written this. So this is for A11. Now for A12, now that is, this is, we consider 2. So when we consider this one, we delete the row and column containing 2. So remaining is 1, 2, 2, 1. So this one. Next, when we consider A13, delete this row column and this row. So remaining is 1 minus 3, 2, 1. So next is for A21, delete the column containing A21 and row containing A21. So remaining is 2, 1 minus 1, 1. And for minus 3, now we will delete this column and this row. So remaining is 3, 1, 2, 1. And for this term, delete this column and this row. So remaining is 3, 2, 2, minus 1. For A31, delete this column and this row containing 2. So remaining is 2, 1 minus 3, 2. And for minus 1, this column and this row. So remaining is 3, 1, 1, 2. And for 1, delete this, we get 3, 2, 1 minus 3. Now to find minus of this, we can calculate. Now you know to find this, cross multiply. So for this term we get minus 3 plus 2 minus 1. For second term, it is 1 minus 4 is minus 3. This is minus 1 plus 6 is plus 5. 2 plus 1 is 3. 3 minus 2 is 1. 3 minus 4, minus 3 minus 4 is minus 7. 4 plus 3 is 7. 6 minus 1 is 5. Minus 9 minus 2 is minus 11. Now so these are minus of the terms of A transpose. Now to find cofactor, we need to multiply minus 1 to the power I plus j. For this term, this is position A11, so I is equal to 1 and j is equal to 1. So when minus 1 to the power 1 plus 1 is 2, that is minus 1 square is plus 1. So minus 1 remains as it is. For this position, this is A first row, second column. So I is equal to 1 and j is equal to 2. So 1 plus 2 is 3. Minus 1 power 3 is minus 1. So multiply minus 1 to minus 3, we get it to be plus 3. This position is A13. 1 plus 3 is 4. So minus 1 power 4 is plus 1. So 5 remains as it is. So similarly, this is position A21. So 2 plus 1 is 3. Minus 1 power 3 is minus 1. So multiply minus. This is 2 A22. 2 plus 2 is 4. So minus 1 power 4 is 1. So 1 remains as it is. This is position 2, 3. 2 plus 3 is 5. So minus 1 power 5 is minus 1. When you multiply minus 1 into minus 7, we get it to be 7. This position 3 plus 1 is 4. So plus 1 multiply by plus 1. This is 3, 2. That is 3 plus 2 is 5. Multiply by minus. Now 3 plus 3 is 6. So plus 1. So minus 1 remains. Now for odd numbers, we get minus 1 power 2k is equal to minus 1. This is an odd number, and for even numbers minus 1 power 2k is equal to 1. So when you get the sum to be even number, write the number as it is. When the sum is odd number, multiply by minus to that position. So now this is adjoint of A. So we have A inverse is equal to 1 by determinant of A into adjoint of A. So now X is equal to A inverse into B. So this is A inverse and into B. Multiply, matrix multiplication, we get 8, 16 minus 8. Now multiply 8 inside, we get 1, 2 minus 1. In initial we written X to be equal to X, Y, Z. Now we got X to be equal to 1 minus 2, 1. Therefore X is equal to 1, Y is equal to 2 and Z is equal to minus 1. So these are the solutions of given system of equations.